sympathy from me. Okay, let's talk about this. Let's talk about ATP. So we can take, and this is what the animation had just showed, we can take ADP and that lone phosphate group. That O, or that circle around the phosphate, means that it's an organic phosphate. And we can make from that ATP. So, in essence, we have taken, or we can take a low energy molecule and make it into a high energy molecule. Now tell me, would this be endergonic or would this be exergonic? Okay, why is it endergonic? Okay, so I think that's very much correct. We want to mention that this reaction would have to be endergonic. Now tell me about, and this is why I want us to know this like the back of our hand, would this reaction be having a delta G that's negative or positive? To make a high energy molecule would be unlikely. So this delta G would be positive. Would we classify this reaction, therefore, as being spontaneous or not so spontaneous? Okay, so not so spontaneous.
So even if it's like a biological process that our body does easily and like on a daily basis.
Right. What this simply means is that if you don't like, me having an Xbox 360 would be a not so spontaneous reaction. I have to put something into it for it to show up at my house. So I've got to buy it, basically. So much like this, I have to buy my ATP. I have to make it using energy. Whenever you have an endergonic reaction, that means, of course, that it is energy requiring. So if something requires energy or money, what do you have to do? You have to spend, right? Spend that which you have. Let's talk about energy and reaction coupling. Now, when you mention the word coupling, to me this refers to an addition effect, an additive effect in which you have multiple reactions coming together. Like we had just mentioned, the production of ATP from ADP in an organic phosphate would be having a delta G that's positive. It's endergonic. It's unlikely to happen. So what do we do to make it happen? I'm watching you guys write, think. Someone's chewing right now. I see a student writing an essay. I'm talking. How is all this possible? I mean, like, we're using all this ATP as we do all those things I just said, right? So how do you get ATP? Do what? And this represents energy. So what if ATP is a high energy molecule, how did you ever get it to be a high energy molecule? Where did you get that energy to put into this ATP? Converted from where? Okay. So as you take a food, right? Like glucose, and you combust it, that means you react it with oxygen. You form some water. You form some carbon dioxide. That is a reaction, since it involves a breakdown, right? And like we could look at this reaction and we could tell very quickly that your delta S is very positive because you're making more molecules. A positive delta S means an increase in entropy. Lots of times when the disorder is increasing, the reactions are likely to be happening, which means your delta G here should for sure be negative. So as we can see, this making of ATP is, as you could guess, and as you can see, is truly ran by and based upon the little food that you have in your body. Now, I will tell you that to make every single molecule of ATP, it has a delta G that is a positive 7.3 kilocalories per mole. Now, factoring out the inefficiency of a biological system, so I'm saying let's pretend that we were 100% efficient. We're not. But what a glucose molecule can bring to the table is about a negative delta G that has a value of about 270 or so kilocalories per mole. Now, that's not true. It's actually more like closer to 1,000, but I'm factoring out inefficiency. I'm factoring out friction, if you will. So for every one glucose molecule that you break down, you can generate 270 kilocalories of energy. Do you see how that says negative? That's energy that's being released because you broke it down. And that energy that's being released is taken and is powering the production of this event. Now, if you do the quick math, you could see that you could generate approximately 37 times of this reaction. You have heard along the way, I hope, that when you do cell respiration, you know, you do glycolysis, citric acid cycle, or Krebs cycle. You've heard of these before. Electron transport chain. Once upon a time, this happened. Do you remember how many ATPs you generated the entire time? About 38 or so. About 38. So every mole of glucose can generate about 38 ATPs.